Bore-drilled holes may contain no more than 3 Romex cables. These cables should not fill more than 50% of the hull's cross-sectional area. This requirement is important for several reasons, primarily related to heat dissipation and safety. When electrical current flows through a cable, it generates heat. If multiple cables are tightly packed within a confined space, such as a bored hull, the heat generated by each cable can accumulate. This accumulation can lead to elevated temperatures within the cables and the surrounding materials. Excessive heat can degrade the insulation of the Romex cables, potentially leading to short circuits, current faults, and even electrical fires. The 50% fill rule is designed to provide adequate airspace around the cables, allowing for sufficient heat dissipation. This helps to prevent the cables from overheating and reduces the risk of insulation breakdown. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety and proper functionality. While the specific section may vary depending on the edition, the general principle of limiting the number of Romex cables in bored holes and adhering to the fill percentage is consistently addressed. It's crucial to consult the latest edition of the NEC and any applicable local codes to ensure compliance. Several factors determine the appropriate number of Romex cables that can be safely installed in a bored hole. Firstly, the size of the bored hole is a primary consideration. A larger hole will naturally accommodate more cables while still maintaining adequate spacing for heat dissipation. Secondly, the gauge or size of the Romex cables themselves affects the fill percentage. Larger gauge cables, which carry high currents, generate more heat and require more space. Thirdly, the ambient temperature of the surrounding environment can influence the heat dissipation capabilities of the cables. In hotter environments, it may be necessary to reduce the number of cables in a bored hole to compensate for the reduced cooling efficiency. When determining the maximum number of Romex cables for a bored hole, it's essential to calculate the cross-sectional area of both the hole and the cables. Firstly, determine the diameter of the bored hole. Secondly, calculate the radius of the hole, which is half of the diameter. Thirdly, calculate the cross-sectional area of the hole using the formula area equals pi times radius squared, where pi is approximately 3.14159. Next, determine the diameter of each Romex cable. This information is typically printed on the cable jacket. Calculate the radius of each cable, which is half of its diameter. Calculate the cross-sectional area of each cable using the same formula, area equals pi times radius squared. Multiply the cross-sectional area of a single cable by the number of cables being installed. This will give you the total cross-sectional area occupied by the cables. Divide the total cross-sectional area of the cables by the cross-sectional area of the bored hole. This will give you the fill percentage. Ensure that the fill percentage does not exceed 50%. If the fill percentage exceeds 50%, reduce the number of cables or increase the size of the bored hole. In some cases, it may be necessary to use alternative wiring methods such as conduit, which provides better heat dissipation and physical protection for the conductors. When running Romex cables through bored holes, it's essential to follow best practices for installation. Firstly, ensure that the bored holes are smooth and free of any sharp edges or burrs that could damage the cable insulation. Secondly, use appropriate cable clamps or supports to secure the cables within the hole and prevent them from moving or rubbing against the edges. Thirdly, avoid bending the cable sharply, as this can also damage the insulation. Use gentle bends with a radius that is at least 5 times the diameter of the cable. Fourthly, when running multiple cables through a single hole, try to space them evenly to promote better heat dissipation. In addition to limiting the number of Romex cables in bored holes, it's also important to consider the overall ampacity of the conductors. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can safely carry without overheating. The NEC provides tables that specify the ampacity of different sizes and types of conductors based on factors such as the insulation temperature rating, the ambient temperature, and the number of conductors bundled together. When determining the appropriate size of Romex cables for a particular circuit, it's essential to ensure that the ampacity of the conductors is sufficient to handle the expected load. The load is the amount of electrical power, measured in watts or volt amps, that the circuit will be required to supply. If the ampacity of the conductors is too low, they can overheat, leading to insulation damage and potentially creating a fire hazard. In some cases, it may be necessary to upsize the conductors to provide adequate ampacity. For example, if a circuit is expected to carry 20 amps of current, it may be necessary to use number 12 American wire gauge or AUG conductors, which have a higher ampacity than number 14 AWG conductors. It's also important to consider voltage drop when sizing Romex cables for longer runs. Voltage drop is the reduction in voltage that occurs as electrical current flows through a conductor over a distance. Excessive voltage drop can cause appliances and equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. To minimize voltage drop, it may be necessary to increase the size of the conductors or use a higher voltage system. When working with electrical wiring, it's crucial to prioritize safety at all times. Firstly, always disconnect the power to the circuit before working on any wiring. Secondly, use appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, double-check all connections to ensure that they are tight and secure. Fourthly, if you are not comfortable working with electrical wiring, consult a qualified electrician. Improper electrical wiring can be dangerous and can create a fire hazard. It's also important to be aware of the potential hazards associated with working in confined spaces, such as attics and crawl spaces. These spaces can be hot, dusty, and poorly ventilated. Wear appropriate respiratory protection and take frequent breaks to avoid overheating. In addition to following the NEC guidelines for Romex cable installation, it's also important to be aware of any local codes or regulations that may apply in a particular jurisdiction. Local codes may have additional requirements or restrictions that are not covered by the NEC. It's always a good idea to check with the local building department or electrical inspector to ensure compliance with all applicable codes. When inspecting electrical wiring, it's important to look for any signs of damage or deterioration. This includes cracked or brittle insulation, loose connections, and signs of overheating. If any problems are found, they should be corrected immediately to prevent further damage or potential hazards. It's also a good idea to periodically test ground fault circuit interrupters, or GFCIs, to ensure that they're functioning properly. GFCIs are designed to protect against electrical shock by detecting ground faults and quickly interrupting the circuit. They are typically installed in bathrooms, kitchens, and other areas where there is a risk of water exposure. To test a GFCI, press the test button on the device. The GFCI should trip and interrupt the circuit. Then press the reset button to restore power. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. Surge protectors are another important safety device that can help to protect electronic equipment from damage caused by power surges. Power surges are sudden increases in voltage that can occur due to lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment. They are typically installed at the point of entry of the electrical service or at individual outlets. It's important to choose a surge protector that is rated for the appropriate voltage and current levels. It's also a good idea to replace surge protectors periodically, as they can degrade over time due to repeated exposure to surges. In addition to surge protectors, uninterruptible power supplies, or UPSs, can provide backup power in the event of a power outage. UPS typically contain batteries that can provide power for a limited amount of time, allowing users to safely shut down their computers and other equipment. UPS are particularly useful for protecting data and preventing data loss during power outages. When installing electrical wiring, it's important to use the correct type of wire and connectors for the application. Romex cable is suitable for many residential wiring applications, but it is not suitable for all situations. For example, Romex cable is not permitted to be used in wet or damp locations such as underground or in direct contact with concrete. In these situations, it is necessary to use a different type of wire, such as underground feeder, or off cable or conduit with individual conductors. It's also important to use the correct type of connectors for joining wires together. Wire connectors are designed to provide a secure and reliable electrical connection. They should be listed by a recognized testing laboratory such as Underwriters Laboratories, ORL. When making wire connections, it's important to strip the insulation from the wires carefully to avoid damaging the conductors. The stripped portion of the wire should be clean and free of any nicks or scratches. The wires should be twisted together tightly and then inserted into the wire connector. The wire connector should be tightened securely to ensure good electrical connection. It's also important to avoid over-tightening the wire connector, as this can damage the wires of the connector. When running wires through walls or ceilings, it's important to protect them from physical damage. This can be done by using cable staples or cable ties to secure the wires to the framing members. The staples or ties should be spaced closely enough to prevent the wires from sagging or rubbing against the edges of the holes. It's also important to avoid running wires through areas where they could be easily damaged, such as behind furniture or in areas where they could be stepped on. When installing electrical boxes, it's important to choose the correct size and type of box for the application. Electrical boxes are designed to protect wire connections and to provide a mounting location for switches, receptacles, and other electrical devices. The size of the box should be large enough to accommodate all of the wires and devices that will be installed in it. The type of box should be appropriate for the location and the type of wiring being used. For example, metal boxes are typically used in areas where there is a risk of physical damage, while plastic boxes are typically used in areas where there is no risk of physical damage. It's also important to ensure that the electrical box is properly grounded. Grounding is a safety measure that helps to protect against electrical shock. The grounding wire should be connected to the metal box or to the grounding terminal in the plastic box. When installing switches and receptacles, it's important to follow the manufacturer's instructions carefully. Switches and receptacles are designed to be installed in a specific way, and improper installation can lead to malfunctions or safety hazards. It's also important to use the correct type of screws to secure the switches and receptacles to the electrical box. The screws should be long enough to reach the framing members behind the box, but not so long that they protrude through the wall or ceiling. When installing lighting fixtures, it's important to choose fixtures that are appropriate for the location and the type of lighting desired. Lighting fixtures are available in a wide variety of styles and sizes, and it's important to choose fixtures that are compatible with the existing wiring and the electrical load. It's also important to follow the manufacturer's instructions carefully when installing lighting fixtures. Improper installation can lead to malfunctions or safety hazards. When working with electrical wiring, it's important to be aware of the potential hazards associated with arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a short circuit or other electrical fault. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, it's important to wear appropriate personal protective equipment such as arc-rated clothing, gloves, and face shields. It's also important to follow safe work practices, such as de-energizing equipment before working on it and using insulated tools. In conclusion, installing Romex cables in board holes requires careful attention to detail and adherence to the NEC and local codes. By following the guidelines outlined above, you can ensure safe and compliant electrical installation. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns.